Hello students, so welcome to chemistry class in NEET Endgame series. Before starting today class, my dear students, I'm going to tell one word now. I'm going to just tell one word now. I will give the clue what will be that word. If I tell that word no, all students will be always feel very happy. If I tell that word, all students will be always feels very happy. Even the last bench students also will feel happy. Guess what is that word? Anybody can guess what is that word, my dear students? So today class, exactly I'm going to start with that word. Why sir? Why? What is the need to exactly start the class with that word? Means here you guys can see these chapters. Inorganic chemistry means always it's about, I'm not only talking in terms of NEET examination, whether it is JEE mains, JEE advanced, state level, central level entrance, whatever, let it be. Inorganic chemistry means we are having only two important chapters. We are having only two important chapters, that is high weightages coordination compound. Next to coordination compound, the next very high weightage topic is D and F block elements. These two topics are really having very high weightage, my dear students. Now tell me, just now I am telling these two topics are very important. Both the chapters are having very high weightage. At the same time, I'm just telling, I'm going to start the class with one word that will make all the students happy. How it is related? Anybody can guess what will be that word? In the meantime, yes, Road to Jibmer, Ananya, A to the world, Kriti, right? So, very good evening, my dear students, very good evening. So, as usual, in today class, we are going to solve different model questions from all these topics. We are going to solve different model questions. See, honestly speaking, if I want to solve, we can solve even 500,000 plus question from each and every chapter. But in an exam point of view, in a very precise way, I don't want to waste you people time also. So what we can do is, in a very precise way, we can able to solve different model question. We can able to solve a different model question. So all those model questions we are going to solve. Before that, one word, what I am going to tell is tricks, or else we can call it as shortcut. When it comes to coordination compounds, majority of the students will be always feeling difficult. Sir, I don't know how to find out the complex name, how to solve. I really don't know, sir. So, my dear students, the first 20 minutes, in a very simple way, I'm going to tell the shortcut to predict the hybridization when it comes to coordination complex. After letting you guys know the hybridization shortcut, automatically you guys can able to solve any question. Not only from today class, any textbook, any PYQ, any material, you guys can able to solve the question. For that, the main thing, you guys need to know the shortcut. So first 20 minutes of class is very important. If you are watching a recorded video also, it is fine. So please do make a note of the shortcut. This shortcut will be really helpful for us to solve any question with respect to hybridization. How many of you gone through JEE mains paper 2026, even January session as well as April session? In each and every session, we got minimum 2 to 3 questions from coordination complex asking about hybridization of the complex. This is very common question in coordination compounds. Definitely, even I will write and sign also. Definitely, we will get for NEET examination also question based on hybridization with respect to the complex. Right? So without any wasting time, we will start the session. I hope by this time everyone know my name, myself Prithviraj Sir. Yes, exactly. So we will start solving the question. Right. First, before starting the session, in today's class, what are all the chapters we are going to discuss means classification of elements and periodicity in properties, followed by P block elements, D and F block elements and coordination compound. Don't worry, my dear students, when it comes to P block elements, we are having only the general properties. We are having only general properties. General properties of group 13 to group 18 elements. Other than this, nothing required. Yes, Aradhana, Dr. Yogesh, very good evening, very good evening. Yes, I will be there also, Yogesh, don't worry. Wait for some days, I will be there too. Right, yes, Tejaswini, hello sir, hello Tejaswini. So as I told, once again, now actually I think maybe, okay, now actually majority of the students are joining. First actually 20 minutes, we are going to discuss the shortcut from the topic coordination compounds, how to predict hybridization. Followed by that, we are going to solve question, then followed by D and F block elements, periodic classification as well as P block elements. Done. First, let me start with the shortcut. Learn the shortcut very clearly. That is very, very important. Okay. Now, before solving question, let me tell with the help of shortcut. For what purpose we are going to do this shortcut? To predict hybridization in coordination complex. Shortcut, let me reduce the thickness. To predict hybridization. To predict hybridization in coordination complex. When it comes to coordination complex, we will be having only two coordination number, right? It is not like hybridization means it's not like chemical bonding. Either we will be having coordination number 6 complex or we will be having coordination number 4 complex. Only these two complex are possible. Coordination number 4 complex or coordination number 6 complex. Listen carefully. First thing, whatever the complex, either whether it is coordination number 6 or coordination number 4. Let me take coordination number 6 complex. What are the two hybridization possible? We know very well, either the hybridization can be sp3d2, we will be calling it as outer orbital hybridization or outer orbital complex, or else one more hybridization, that is d2sp3. I will be calling this d2sp3 as inner orbital hybridization or inner orbital complex. Only these two hybridization are possible. We all know very well. When it comes to coordination number 4, only two hybridization is possible, sp3 or it can be dsp2. Once again, I am telling, please do listen carefully. When it comes to coordination number 6 complex, when it comes to coordination number 6, we will be having only two complex, that is sp3d2, d2sp3. When it comes to coordination number 4, we will be having only two complex, that is sp3 or dsp2. It is clear? Clear? Now, sp3d2 means outer orbital hybridization, d2sp3 means inner orbital hybridization. How to find out? Sir, you told the shortcut, but you are teaching the theory. Let me tell, wait. In a question paper, whoever the question paper setter, coordination compound means definitely in front of us, complex will be there, right? In front of us, complex will be given. Whatever the complex, let it be, definitely there will be a presence of metal inside the complex. So the first thing is, we need to find out what is the oxidation state of central metal atom present in the complex. We need to find out the oxidation state of central metal atom which is present inside the complex. If suppose, let me take any particular metal, if it is present in some 2+ state, with the help of electronic configuration, we can able to tell how many d electrons are present in that particular metal. We can able to find out. If I come to know this particular metal present in +2 oxidation state, automatically I can able to calculate how many number of d electron is present in that metal. We can able to tell. That is the shortcut, my dear students. If suppose in a given complex, the central metal atom in the respective oxidation state, if it is having D0, D1, D2, D3, D4, D5, D6, D7, D8, D9, D2. These are all the different number of d electron possible. Do you people agree or not? Yes. These are all the different d electrons possible for the central metal atom exist in particular oxidation state which is present inside the complex. Directly I am telling, no need to waste our time. In a particular oxidation state, if the central metal atom is having electron from D0 to D3, then remember my dear students, always the hybridization is D2sp3. Always the hybridization is D2sp3. No exceptions, nothing. No exception, nothing. Directly, this is the complex given in the question. Find out the oxidation state of central metal atom. Calculate the number of electrons. If the number of electrons comes out to be 0 to 3 in D subshell, automatically, always it is D2sp3 hybridization. If suppose number of electron comes out to be D7 to D10, then it is always sp3d2. Then it is always sp3d2 hybridization. Now the question will come, sir. Okay, sir, super. We understood the shortcut, but what about this particular d4, d5, d6 electron? Now the question will come. Whatever you are telling is fine, sir, but what about these three d electrons, d4, d5, d6? Then we need to solve with the help of crystal field theory. Sir, what, sir? You told to shortcut this crystal field theory only is the problem for us. Very simple. We no need to learn this crystal field theory and all, my dear students. In a very simple way, I am going to tell. How to solve with the help of crystal field theory? Understand? We need to check if the central metal ion in the particular oxidation state, if it is having d electron 4, 5, 6 means, then we need to check whether the particular metal belongs to 3D series or 4D series or 5D series. If the central metal atom belongs to 4D or 5D series, whether it present in +2 oxidation state, +3 or +4, whether it is 5D series element, it exists in +2, +3, +4 oxidation state, no problem. In both the cases, what we know, all ligands are strong field ligand. If suppose if it is 3D series element, if 3D series element exists in +2 oxidation state, then only carbon donor ligand is strong field. If the same 3D series metal exists in +3 oxidation state, carbon nitrogen donor is strong field. If the same 3D series metal exists in +4 state, carbon nitrogen oxygen donors are strong field ligand. Everybody is getting idea? Now the question will come. Sir, you told us you will tell the shortcut to calculate the hybridization. But in the shortcut you are telling us whether the given ligand is strong field or weak field. How we can able to find out the hybridization? Remember one simple thing, my dear students. Strong field ligand, weak field ligand. What is strong field ligand? Splitting will be more. When the splitting is more, do you think the incoming electron can go and occupy the upper energy level? Imagine, come out of chemistry with a basic common sense in science. Strong field ligand, splitting between d orbitals will be very high. If the splitting is very high, do you guys think the incoming electron will come and occupy the upper energy level? No, it is not possible because energy difference is very high. So automatically what will happen? It will come and occupy the lower energy level position. So pairing will take place. If it is a strong field ligand, pairing will takes place. Weak field ligand means pairing will not takes place. If pairing takes place, what is the hybridization? D2sp3. No pairing means it is sp3d2. It is clear. It is clear. Anybody is having any doubts? That's all. Now tell me, strong field ligand means, then what is the hybridization? Strong field means D2sp3. Other than carbon, nitrogen, oxygen donor, if suppose I am having halogen donor, then it is weak field ligand. Hybridization will be sp3d2. Now one more question will come to the student's mind. Sir, what is this carbon donor, nitrogen donor? If we look into the spectrochemical series, carbon donor means CN and CO ligand. Nitrogen donor, NH3, ethylene diamine. Oxygen donor, water, oxalate, then halogen, sulfide. If you look into the spectrochemical series, we can able to tell, right? No need to memorize spectrochemical series also. Easily with the help of this shortcut, you guys can able to solve question. Now, shall we try some questions with respect to coordination number 6? Don't worry, for coordination number 4, I will give. For coordination number 4, I will give the idea. Because this page is completely occupied, right? In the next page, I will do. Now, everyone understood how to solve hybridization based question when it comes to coordination number 6 complex. Shall we try some questions now, my dear students? Shall we try? Shall we try some question now? Is everyone is ready? Right, fantastic. Now, let me give one question, because this is what very important when it comes to question solving. FeCN6 4 minus. FeCN6 4 minus. Next one, ZnH2O6 2 plus. Imagine we are sitting in the exam hall. Quickly calculate hybridization and tell me, my dear students, for both. Calculate hybridization. Calculate hybridization. How we can able to calculate for these two particular complexes? How we can able to calculate? Let me know. This one complex, this is another complex. How we can able to calculate? Yes. How we can able to calculate? Let me apply the shortcut. Listen carefully. FeCN6 4 minus. What is the central metal atom? Fe, fine. What is the oxidation state? We know to calculate oxidation state. X, Cn is anionic ligand. 6 Cn is there, so minus 6 is equal to minus 4. X will be equal to minus 4 plus 6. So X will be plus 2. That is central metal atom Fe present in plus 2 oxidation state. Central metal atom Fe present in plus 2 oxidation state. Now, tell me which complex is this? Question paper setter is dealing with coordination number 6 complex. Fe2 plus means what will be the d electrons? We know very well Fe, Cr, Mn, Fe, right? Don't look into the Kriti answer. Oh, she is my student already. She knows the shortcut. So others. Fe, what is the electronic configuration? 4s2, 3d6, right? Cr, Mn, Fe. Now, Fe plus 2 means what we will be having? 4s0, 3d6. Now tell me, 3d6 means what we need to do? D6 means CFT theory shortcut. Now, iron belongs to which series metal from periodic table? We know very well. It belongs to iron, 3D series metal Present in which oxidation state? +2 oxidation state. According to the shortcut, carbon donor means strong field ligand. Which ligand is this? CN. What is the donor atom? Carbon donor. So automatically carbon donor is present. So it is strong field ligand. Strong field ligand means what will happen? Pairing will take place. So hybridization will be D2sp3. D2sp3. What is this D2sp3? Inner orbital hybridization or inner orbital complex. That's all, my dear students. Anybody is having any confusion here? So like this, we can able to solve the question in less than 30 seconds. Now tell me, let me give 30 seconds time. Calculate hybridization for this second complex and let me know the answer. Let me give, no need of 30 seconds. Let me give 1 minute time. Calculate the hybridization of this particular complex and let me know the answer quick. Yes. Quickly solve and let me know the answer. Quick, quick, quick. Yes. Last 13 seconds. How we can exactly able to solve this? 4, 3, 2, 1. That's all. Very simple. How we can able to solve? Once again, Z10H2O6. What is the central metal? Z10. H2O is neutral ligand. What is the oxidation state? +2. So Z10 +2 means, Z10 means we know very well, 4s2 3d10. So Zn 2 plus means 3d10. Now in the central metal ion, in the particular oxidation state, it is having 3d10 electron. So d10 electron means always sp3d2. No need to solve anything, no need to calculate anything. So the hybridization is sp3d2. sp3d2 means actually it belongs to outer orbital hybridization or outer orbital complex. That's all, my dear students. As simple as that. Good evening, sir. How everything is going on? Yes, it's going good. Get ready to solve questions, my dear students. I am not the person, I will teach only shortcuts. That's all you guys can do. No. Now, after doing the tetrahedral shortcut, directly we are going to solve different model questions from coordination compounds. Okay. Then now it is very much clear. I believe now it will be easy for each and every one of you to solve any questions. Right? Any question with respect to coordination chemistry, not quantum chemistry. Done? Okay. Now, let me continue with coordination number 4. As I told in the beginning, coordination number 4 means two hybridizations are possible. It can be sp3 or it can be dsp2. What is the shortcut? The same shortcut only, my dear students. We will be having the same shortcut. The same step. First, we need to find out what is the central metal ion, what is its respective oxidation state. In that particular oxidation state, how many d electrons are present? What are the possibilities? Let me write d0, d1, d2, d3, d4, d5, d6, d7, d8, d9 and then d10. Listen carefully now. Two hybridizations are possible. So from D0 to D7, let me use different color. From D0 to D7, it is always sp3 hybridization. When we are calculating how many d electrons are present in the particular central metal ion in its respective oxidation state, if the d electron comes out to be between 0 to 7, then it is always sp3 hybridization. If it is d10 also, then it is sp3 hybridization. As usual, as we discussed for coordination number 6, when it comes to coordination number 4, where we need to apply shortcut when we are dealing with a D8 and D9. When we are dealing with D8 and then D9. What is the shortcut? Apply CFT theory. As just now I told, strong field ligand means pairing will happen. Weak field ligand means no pairing. In a strong field ligand, when pairing is happening, my dear students, listen carefully. When pairing is happening, what will be the hybridization? DsP2. Weak field ligand means sp3. When it comes to D8, D9, once again CFT theory. Look at to which series the central metal atom belongs to. If the central metal atom belongs to 3D series, present in +3 +4 oxidation state, 4D series metal present in +2 +3 +4 oxidation state, 5D series metal present in +2 +3 +4 oxidation state, then automatically in all these cases, all ligands are strong field ligand. In all these cases, if all ligands are strong field ligand, automatically what we can able to tell? Strong field ligand means pairing will take place. If pairing is taking place, hybridization will be DsP2. Everybody is clear? Suppose if I am having 3D series metal present in +2 oxidation state, then definitely we need to think 2 hybridizations are possible. What are the 2 hybridizations are possible? Listen carefully. After H2O ligand, in what? Spectrochemical series. I hope everyone knows spectrochemical series, right? Just now board exam has been completed for 12th class students. 11th class students, don't worry. Now this is crash course. I will be helping you guys out. When regular classes started, don't worry. After H2O, in a spectrochemical series, all ligands are strong field. So strong field means pairing will take place. What will be the hybridization? DsP2. Here what will be the hybridization? DsP2. Before H2O as well as before H2O. Before H2O, please include H2O also. Including H2O. In a spectrochemical series, those ligands are weak field ligand. So automatically, what will be the hybridization? What will be the hybridization? sp3. All ligands are weak field ligand. It is clear. Now, let me solve one question. Automatically, you guys will get a clear-cut idea. Please do make a note of it. So, let me solve the one question. Please do make a note of this, my dear students. Quick. Please do make a note. Already it is 6:30. We need to start solving question. That's all about shortcut. Very simple. Now, let me give one question. Try to solve, my dear students. Let me take Ni. There I can't able to write N. Ni CN4 2 minus. NiCN4 2 minus. Calculate hybridization. What will be the hybridization? Let me give 1 minute time. Use shortcut. Use only our shortcut. Quick. Yes. Yes. What will be the hybridization? Yes. DSP2. Shall we check? So what will be the hybridization? The same. What is the question solving approach? What is the central metal atom? N9. What is the oxidation state? +2 oxidation state. X, Cn is anionic ligand, 4 anionic ligand is there. So X minus 4 is equal to -2. X will be equal to -2 plus 4. So X will be equal to +2. Ni exists in +2 state. When it comes to Ni, what is the electronic configuration? CrMn FeCO Ni 4s2 3d8 28. So Ni2 plus means what will be the electronic configuration? 4s0 3d8. Now tell me 3d8. What we need to do? 3d8 means we need to check for CFT shortcut. What is the shortcut? We need to check which series metal. Ni belongs to which series? 3D series metal present in +2 oxidation state. 3D series metal +2 oxidation state. This is +3 +4. So +2 oxidation state means the ligand, the given ligand Cn present before water in spectrochemical series or after water in spectrochemical series. We all know very well, after water in spectrochemical series. So automatically after water, if it is present in spectrochemical series, the ligand will be strong field ligand. So strong field ligand means what will be the hybridization? Cn is strong field ligand. So automatically what will be the hybridization? DsP2. Now DsP2 means what will be the geometry? DsP2 means it is square planar. Sp3 means it is tetrahedral. That's all, my dear students. So with the help of this shortcut, we can able to solve any hybridization related question when it comes to coordination complex in a less than 30 seconds. Now one thing will come always in chemistry. Sir, you told a shortcut, any exceptions are there? Only one exception is there with respect to shortcut. When it comes to coordination number 6, what I told actually? 3D series metal +3 oxidation state means carbon nitrogen donor or strong field. I told, right? Only one element is an exception, cobalt. When 3D series metal cobalt present in 3+ state, not only carbon nitrogen, oxygen also it is a strong field ligand. Oxygen also strong field ligand. This is the only one exception. Apart from this, there is no exception. Easily with the help of this shortcut, we can able to solve any hybridization related question with respect to coordination complex in less than 30 seconds. Now tell me, my dear students, anybody is having any doubts in the shortcut? One more thing. Okay, sir, metal carbonyls comes in the exam. Can I use this shortcut? Metal carbonyls is completely different chemistry because metal exists in zero oxidation state. This shortcut is applicable only for normal complexes, not for metal carbonyls. Please do keep this in mind. Clear? Anybody is having any doubts now? Now, shall we start solving the questions? Now, different model questions we are going to solve in chapter wise, that is coordination compounds, D and F block, P block, periodic classification. Try to tell the answer correctly. Okay? Right. Please do make a note of each and everything. If possible, please do take a screenshot. That's why actually I'm giving time. Yes? First, shortcut. Second, example. Third one, shortcut. Again, example, how to apply shortcut. First question for the day in coordination compound. Yes. Let me start from coordination compound only. This is P block, D block. Yes. 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 First question for the day. So we are going to start solving. These questions are from chapter coordination compounds. The very first question. Yes. Which of the following compound will give the test of Fe2 plus in aqueous solution? So let me start the poll. Very simple. There is no separate method or you guys can join the poll. No, nothing like that. Once I start the poll, try to tell your answer in the comment section. Automatically things will be captured here. It is clear. Try to answer, my dear students. Now, since initial days, I am just starting with timeless poll. Quick. But I need the answer in less than 30 seconds. In the upcoming days after 20th, I will tell you guys how we can increase the speed, all those stuffs. Now, tell me. Which of the following compounds will give the test of Fe2 plus in aqueous solution? Oh, very nice thing here. What you guys are observing here? Yes, what you guys are observing here? So both options C and D are same. So accordingly, what is the thing will come? Let me keep it as C. So accordingly, what will come? Option C. Why option C is the answer? If you look carefully, whatever the ions present inside the complex, do you think, guys, these ions will come out? No. If I put this coordination complex in the solution, it will dissociate as 4K plus FeCN6, 4 minus 4 positive charge, so 4 negative charge. How this will get dissociate? 3K plus FeCN6, 3 minus. So automatically, this is the difference between double salt and coordination compound. Coordination compound do not lose their identity. If it is, what happened? King Lucifer, dominant mode. So when it comes to double salt, we will get, if I dissolve this in aqueous solution, what exactly will happen? From this, ammonium ion will come out, iron ion will come out, sulfate ion will come out. But when it comes to coordination complex, whatever the metal ion or ligand present inside the coordination complex will not come out. So coordination complex do not lose their identity, but double salts will lose their identity. Very simple thing. Example difference between double salt and coordination compound. So option C is the correct answer. You guys can keep option D as none of the above, my dear students. That is better. So you guys can keep it this as none of the above. Same options are given. Then next question. How many moles of AgCl would be obtained when 100 ml of 0.1 molar CONH35Cl3 is treated with excess of AgNO3? Nothing, sir, just slightly confused but understood now. Okay. Yes, tell me. How many moles of AgCl would be obtained? Yes. How to solve this question? Very simple. First, actually, we can see 5 ligands are there, here 3. So coordination number will be 6. So what is the complex? CONH35Cl. Outside the square bracket, we will be having Cl2. How this will get dissociate? We know very well how this will get dissociate. This will dissociate as CONH35Cl. Outside the bracket, 2Cl is there. That means 2Cl minus, total minus 2 charge. So here we will be having plus 2 charge. Now, How many moles of Cl minus is present outside? 2 moles of Cl minus is present outside. So automatically, if I react with AgNO3, what will happen? Only this 2 Cl minus will react with AgNO3 to give AgCl. Am I right? Only this 2 Cl minus will react with AgNO3 to form AgCl. Listen carefully, but the question is all about how many moles they are asking. So when it comes to how many moles, we know very well, molarity is nothing but number of moles upon volume. So number of moles means molarity into volume. What is the molarity? 0.1. What is the volume we are having? 100. 100. Otherwise we can write it as 0.1. Right? So in liter, I am writing in terms of liter. So automatically this will be 0.01. 1 into 10 to the power minus 1, 1 into 10 to the power minus 1, 1 into 10 to the power minus 2. 0.01 moles. If I take 0.01 mole of this, now think carefully, how many moles of Cl minus we are having? 2 moles of Cl minus. So automatically into 2, how many moles of AgCl we will get? 0.02 moles of AgCl we will get. Option B is the right answer. Option B is the right answer. It is clear? Very simple question. Next question. The same thing, but little bit tough question. As I told, I will be focusing on different model question. If you people solve these model question, it is more than sufficient, my dear students. Maybe we will get one model question from the same thing in our NEET examination, or else the same questions also may be asked. 0.001 mole of CONH35NO3SO4 was passed through cation exchanger, and acid coming out of it required 20 ml of 0.1 molar NaOH for neutralization. Hence the complexes. Very easy question. See, they are not even wasting our time by asking us to do numerical. Question paper setter is a very good paper setter. Tell me, my dear students. Yes. Yes. Quick, what will be the answer? Think. This much actually 0.001 mole of this complex was passed through cation exchanger. So cation will be exchanged. Acid coming out of it required 20 ml of NaOH. So how many moles of NaOH will be there? How many moles of NaOH we will be having? 20 ml. So 0.02 liter into 0.1. So 2 into 10 to the power minus 2, 1, so 2 into 10 to the power minus 3. So automatically we will be having 0.002 moles. 0.002 moles of NaOH we are having. Now, yes. Now very simple. This much NaOH is required for neutralization of acid, means how much acid need to come out? Acid also need to come out 0.002 moles. Now 0.002 moles of acid need to come out, means understand, passes through cation exchanger, NO3 minus, SO4 2 minus, NO3 minus. So automatically in what case we will be exactly having 0.002 mole. If this complex get dissociated, we will be having, yes, this complex will get dissociated, we will be having 2 minus. So we will be getting 2H plus, right? Cation exchanges. So 2 negative charge. So 2H plus ion will be comes out as the acid. So 2H plus ion means automatically moles also will be 0.002 mole. N factor. That's all. So correct answer is option B. Who is asking doubt actually? King Lucifer? Sir, just asking, is it fine? I can attend poll, just worried. That is fine. Okay, next question. It is clear. So these are all the different model question. Those who are listening to the lecture now, there is one saying, right? Sorry, due to certain things, just now I am joining the class, sir. Very sorry. If that is the thing, please do go and watch the beginning of the video. I given the shortcut to calculate hybridization for coordination complex. This question, quick. You guys can see how actually I took the question. When H2S is passed through cupric salt added to excess of KCN. Remember, not cuprous, cupric salt added to excess of KCN, no black precipitate of CuS is obtained. Why? Why no black precipitate of CuS is obtained? Yes, yes, yes. Yes, yes, yes. Let me check how many of you can able to tell the answer. If it is theory based means it is very easy for us to tell the answer. Cu2 plus is very small compared to S2 minus ion. This is very small compared to S2 minus ion. So precipitate formation is not at all happening. This is foundation level chemistry, theory based chemistry. But here we need to think in terms of complex. So here also Cu exists in plus 2 state, here also plus 2 state. Here Cu exists in which state, my dear students? Calculate what will be the oxidation state. X minus 3 is equal to minus 2. X will be equal to minus 2 plus 3. So X will be equal to plus 1. Here, what is the state? X minus 6 is equal to minus 4. X is equal to minus 4 plus 6. X will be equal to plus 2. Here, x minus 4 is equal to minus 2. So x is equal to minus 2 plus 4. X will be equal to plus 2. Now from the lower classes we know copper. What is the most stable oxidation state of copper? That is Cu plus 1, right? Why Cu plus 1 is the more stable state? Because we will be having 4s0 3d10 configuration. Cu means 29, 4s1 3d10. Right? So automatically what will be the correct answer? Remember now onwards, this will be the correct answer. Because why? This is the stable complex. When H2S is passed through cupric salt added to excess of KCN, what complex we will be getting? Means we will be getting K2CuCN3 complex will be formed. Which complex will be formed? K2CuCN3. This is the stable complex. Everybody getting an idea? Yes, right? So this is very, very important. Excess of KCN. If suppose they are not passing excess of KCN, only KCN, not in excess means, then what complex we will be getting? Cu2CN2 we will be getting. We will be getting CN2, CN2. But remember, since we are passing in excess, automatically this will give rise to which complex? K2CuCN3. This is very stable complex, my dear students. This is very stable complex. So option C is the right answer. Option C is the right answer. Even my existing students can able to feel the difference. In different batch, I will be approaching in a different way. So please do make use of all the notes. That is very, very important. Okay. Next question. Cu2 plus show a coordination number of. I want each and every one of you to tell the answer. Cu2 plus show a coordination number of. Quick. Yes. Cu2 plus show a coordination number of. 2 only, 2 or 4, 4 only, 4 or 6. Yes. Don't think these are all complicated questions, my dear students. Tell me, when it comes to coordination number, what are the things possible? Coordination number 4, coordination number 6. 2 and all anywhere we are doing, my dear students, any complex. So now the question is 4 only or 4 or 6. You guys tell me, with respect to copper, we are having only 4 complex, coordination number 4 complex. No, both 4 and 6 are possible. So option D is the right answer. Option D is the right answer. Why it is loading? Yeah, option D is the correct answer. Good. Next question. Which of the following is not chelating a ligand? What is chelating ligand? Chelating ligand means chelating agent. That means there will be a formation of ring. Ring formation will take place after it binds a metal. Now in this, which one is not a chelating ligand? Direct question. What is the answer? What is the answer, my dear students? Quick, let me know what is the answer. Yes. A. Why A exactly? A is the correct answer. Why? Thiosulfato. S2O3 2 minus. If I take thiosulfato ligand, it is basically a monodentate ligand. It is basically a monodentate ligand. So do you people think ring formation is possible, my dear students? If it is a monodentate ligand, ring formation is not at all possible. So automatically oxalato, glycinato, ethylene diamine, all these three are bidentate ligand. All these three ligands are bidentate ligand. So only option A is the correct answer. Bidentate means from two binding site it will bind the metal. Automatically there will be a formation of ring. Next. Which of the following has 5 donor site? Which of the following has 5 donor site? Very simple. If we know the structure, we can able to tell the answer. 5 donor site. Yes, yes, yes. One person B. Ethylene diamine. 2 will be there. Ethylene diamine. 2 will be there. Tetraacetate ion. 4 will be there. Triacetate ion. 3 will be there. Now tell me what is the correct answer? Correct answer is option C is the correct answer. Ethylene diamine, triacetate ion. Ethylene diamine, tetraacetate ion means how many we will be having? It will be having 6 coordinating site. It will be having 6 coordinating site. If I talk about this one, this is having 5 coordinating site. Everybody getting the idea? So this will be having 5 coordinating site. 6 donor is B, but the question is all about 5 donor they are asking. 5 donor means option C is the right answer. Next question. Yes. Compound contain 1.08 mole of Na, 0.539 mole of Cu, 2.16 mole of F. Its aqueous solution show osmotic pressure which is 3 times that of urea having same molar concentration. The formula of the compound is. That was close. Hey, how da it will be close? Question is all about 5, but you people are telling 6 as the answer. See, in my class, so many backbenchers are there. Tell me. Osmotic pressure. Osmotic pressure which is 3 times that of urea having same molar concentration. Formula of the compound. Yes, yes, yes. Sir, first I thought both options same. Very good, very good. Sorry, sir, careless mistake. No problem, no need of sorry. Sahana Sri, welcome to the class. Why, ma? I should not be here, huh? Any problem is there, huh? Quick. So, again, one of my existing student came. Please tell me the answer for this question and you can continue, ma. Now students will think, "Arey yaar, this sir is asking different question in different batches." Tell me, quick. What will be the answer? Yes. It's very simple. Listen carefully. Sodium. What is the mole they given? 1.08. Copper 0.539. Next, fluorine 2.16. What we know very well? Yeah, don't worry, Shahana Shri, no one is there to replace me, right? There also I will be only handling chemistry, don't worry. Yes, sodium is 1.08, copper is 0.539, fluorine is 2.17. Now tell me, all the 3 elements given in the question, they given the mole value. Now it is possible for us to calculate molar ratio. Now it is possible for us to calculate molar ratio. How we can able to find out molar ratio? It is very simple. How we can able to find out? Just sodium. Molar ratio will be 1.08 divided by, which is the small number, 0.539. Here 0.539 divided by 0.539. There automatically what will be the molar ratio we will be having? 2.16 divided by 0.539. Now tell me, that's all. Chemistry is gone. Now mathematics. 1.08 divided by 0.539. Approximately what we will be having? So 2 times. 0.5 into 2. Approximately this is 2 times. This is 1 time. Here how many times we will be getting? 0.5 upon 2.1 I am having. So 4 3s are 12, 4 5s are 20, 21, 2.12. Yeah, 4 times. Now, what will be the formula we will be having once we know the molar ratio? What will be the empirical formula? Empirical formula is sodium 2 times, copper 1 time, fluorine how many times we are having? 4 times. So, Na2CuF4. Now, tell me my dear students, if I dissociate this complex, what exactly I will be getting? Listen, up to here I done. This question is very important, my dear students, in exam point of view. Why? This question is a combination of coordination compounds plus solution chapter, osmotic pressure, plus we are having empirical formula concept also. So this model question is very important for NEET as well as JEE Advanced. Combination question. These type of question we need to give high priority whenever we are preparing. That is the reason I am taking this question and I came to today's class. EF means empirical formula. What is the empirical formula we are getting? Na2CuF4. Now tell me how this exactly will get dissociated, my dear students. We all know very well. This will dissociate as 2Na plus CuF4 2 minus. Now automatically what is the Van 't Hoff factor? I from solution chapter, from liquid solution in 12th class, what exactly we will be getting? Sir, please tell the batch name for NEET 2028 for English medium. Yes ma, Arjuna NEET English 2027. That means I will be teaching 11th class portion in that particular batch, Arjuna NEET class 11. Year mentioned was 2027, but NEET exam when you people are going to write in 2028 only. Then why sir it is Arjuna NEET 2027 means from 11th class itself, in 11th class portion itself, I will be started teaching you guys in pure English all the NEET level concept. From basic concepts of chemistry, from mole concept, I will be teaching in everything up to NEET level. Okay, yes. Kriti, advanced, yeah, this type of question is very, very important. So for Tamil Nadu, okay, there is no particular batch for 2028 ma. Only in pure English batch is there. So you can enroll in that batch. So nothing problem. Everything is simple. I will be only there everywhere. So you can do it. Only for NEET 2027 we are having. Okay. Yes. Clear. Now what will be the Van 't Hoff factor? Van 't Hoff factor will be 2 plus 1, 3. Van 't Hoff factor will be 3. Now, osmotic pressure, which is 3 times that of urea having same molar concentration. Now, automatically we will come to know what will be the answer. Urea as well as this one. So, molar concentration is same. We know very well osmotic pressure is directly proportional to concentration. 3 times means then Van 't Hoff factor should be 3. So, Van 't Hoff factor should be 3. Here, what will be the Van 't Hoff factor? 4 plus 1, 5. Here, what will be the Van 't Hoff factor? 1 plus 1, 2. Here, what will be the Van 't Hoff factor? 2 plus 1, 3. So, here, what will be the Van 't Hoff factor? We will be getting 2 plus 1, 3. So, these two is an incorrect answer. But if I compare these two, which one will be the correct answer? From empirical formula, we know this is the correct answer. That is why. So, as a question paper setter, they will check the knowledge of empirical formula also. So, what is the correct answer? Option C is the correct answer. Everybody getting an idea? One of the very, very important model question when it comes to coordination compound chapter. One of the very important model question when it comes to coordination compound chapter. It is clear? Amazing, sir. Thank you, ma. See, it's not about amazing. I want you guys to practice these type of questions. That is the reason in a very precise way, in the beginning of the class, I given shortcut. Now, I am solving different model question. That's all. Apart from this, what is required? That's all. Chemistry will be always easy. Next question. Okay, here they are checking the IUPAC name knowledge. The IUPAC name of the red color. Who wants that is red color or green color? Yeah, it is very complicated, sir. Obtained from reaction of Fe2 plus and dimethyl glyoxime. Nice person, right? They itself given the ligand name dimethyl glyoxime. Now, what will be the answer? Quick. Yes, we need to know the oxidation state. First of all, dimethyl glyoxime is anionic ligand or cationic ligand. Then only we can able to solve the question. Yes. King Lucifer, I am still not good in nomenclature, sir. Then when you will master the nomenclature, ma? What will be the oxidation state of iron? +2. That is no. Dimethyl glyoxime is anionic ligand, -1 charge. Here -2 is there. So automatically X -2 will be equal to 0. So X will be equal to +2. Overall charges, nothing is there. Fe +2. Now, if nothing is given, we need to consider this as cationic complex. If no charge is there, if it is neutral, then we need to consider this as cationic complex. In cationic complex, what metal name will be there? Metal name will come as iron only. So this is ferrate. Iron 2, iron 2, iron 2. Now, ligand name is dimethyl glyoxime. That means in the ligand name itself, di, tri, all this tetra, numerical prefixes are there. Means then we will be using bis, tris, tetrakis, all these things we will use. Now, how many dimethyl glyoxime is there? 2 is there. So, bis should come. Bis, bis, bis. Now tell me, ligand name dimethyl glyoxime, can I call like that only? No, we will be having certain rule, right? For ligand, CN, cyanide, but we will be calling it as cyano. F, fluoride, but we will be calling it as fluorido or fluoro. I hope you people remember. When it comes to ligand name, ITE means ITO, IDE means IDO. You people remember? Yes, ATE means ATO, nitride, nitrite, nitrate. So automatically the same name will come, my dear students, the same name will not come, ligand. So ligand, dimethyl glyoxime. So automatically oxymato should come. So oxymato, oxymato, dioxymato, dioxymato. Now the question is all about this one. 2,3 butane diol dioxymato or 2,3 butane dione dioxymato. What exactly will come? OL. OL represents what, my dear students? Alcohol. ONE represents ketone. Dimethyl glyoxime. So that will come under which category? Automatically, option D is the correct answer. So option D is the correct answer. Option D. Yes, Ananya. Very good. So option D is the correct answer. Everybody getting the point? How to solve these type of question? So my thing is, once the class get over, download the notes from our WhatsApp group. I hope everyone will be in their WhatsApp group, right? So download the class notes. Try to solve question once again. These are all the different model questions. Share it with your friends also. Clear? Next question. When HgI2 is added to excess of aqueous Ki, mercury largely exists as Hg2I2, Hgi3, Hgi4 2 minus, none of these. Yes. Tell me, my dear students, what exactly we will be getting? King Lucifer, one more time, sir. I will be explaining you in our existing batch drama. Don't worry. I am the one teaching. You are not even focusing. Yes, tell me. What will be the reaction? Direct reaction based question. No need to break our head. It's a direct reaction based question. Yes. Direct reaction based question. Very simple. At least from now onwards, please do remember what is the thing we are taking? HgI2. When reacts with Ki, automatically we will be getting HgI4 2 minus. They told excess of Ki, 2 Ki. So automatically we will be getting K2HgI4. This will dissociate as 2K plus plus HgI4 2 minus. HgI4 2 minus. So what will be the correct answer? Option C is the correct answer. So option C will be the correct answer. Done? Everybody getting the point? It's clear? No doubts, right? Fine. Next question. Solution of AgBr in presence of excess of NH3 contains mainly the cation. Quick. Solution of AgBr in presence of large excess of NH3, ammonia, contains mainly which cation will be there? Yes, yes. What will be the answer? Solution of AgBr in presence of large excess of NH3. Exactly. Very good. Very good. Option D is the right answer. Now what will happen? AgBr. If I treat with excess of NH3, they mentioned excess. So automatically we will be getting AgNH3 twice. What is the silver stable state? Plus 1. So automatically we will be having Br minus. So AgNH3 2 plus. Option D will be the correct answer. Option D will be the correct answer. Yes. Blissy, they mentioned here excess, right? So excess means more than 1 mole of ammonia we will be having. So that is the reason here too. Here 1 excess. Option D is the correct answer. Next question. Molar ionic conductance of octahedral complex. Quick. Now tell me, molar ionic conductance depends on what? Number of ions. Now dissociate and let me know. Quick. Yes, yes, yes. This question is based on what? Werner's theory, right? This question is completely based on Werner's theory. Yes. Try to solve this particular question. B. Let me check. B. Okay, everyone started telling B, B, B. Let me check. Others can also tell your answer. In the meantime, I will cross check. PtCl4 5NH3. That means Pt NH3 5 will be there. Cl. Outside we will be having Cl3. Right? That means we will be having 3 Cl ions we will be having. Am I right? So we will be having Cl3 ions. This is actually first one. Second one. If I take second one, 4 NH3 is there. So PtNH3 4, coordination number 6 complex. So I need to balance by putting 2 Cl2. So automatically balance how many? 4 Cl. So we will be having Cl2 outside. Next, third one, Pt 3NH3 is there. I need to balance coordination number 6 by adding another 3 Cl. So only 1 Cl is left. That will come outside. Fourth one, if I take Pt, only NH3 twice is there. 4 Cl I need to add. All the 4 Cl is there. So nothing will be left over outside. Now, we know very well ionic conductance means it depends on number of ions, right? So calculate what will be the number of ions. If this get dissociated, any ions will come out? No. Actually, we will be getting 0 ions. If this dissociate, this Cl will come as Cl minus. So 1 ion. If this get dissociated, Cl2 will come out as 2 Cl minus, 2 ions. If this get dissociated, Cl3 will come out as 3 Cl minus ion. So 3 ions. Now automatically which one is having more conductivity? 1. Least is 4. So 4, 2, 3, 1, 1, 4, 4, 1. Option B is the right answer. Option B is the right answer. Everybody is getting a clear-cut idea how exactly I'm solving this sort of question. Some students confused with option D. 4, 3, 2, 1. Number of ions. Option B is the correct answer. One of the basic questions. Next question. On treatment of 100 ml of 0.1 molar solution of complex. 100 ml of 0.1 molar. So what will be the number of moles? 100 ml of 0.1 molar. 0.1 into 100 ml means 0.1. So automatically we will be getting 0.01. 0.01 moles of what? Complex. Complex concentration is 0.01 mole. I am treating this with excess of AgNO3. Remember, they are treating this with excess of AgNO3. But how many gram of AgCl was obtained? 4.305 gram of AgCl was obtained. Now the question is all about what is the following complex? Yes, very good question. Now, what will be the AgCl molecular weight? AgCl 108 plus 35.5. So 143.5 molar mass of AgCl. How much we are having? 143.5. So from this it is very easy for us to calculate number of moles of AgCl. Number of moles of AgCl is 4.305 divided by 143.5. So if we solve this, approximately how many number of moles we will be getting? Yes, 0, 3 times 3 3s are 9, 3 4s are 12, 3 1s are 3, yeah, 429 will come. So approximately 3 times, right? So here, if I remove the decimal place 3 times, here actually minus 2, minus 1, minus 3. So 0.003 moles. How many moles I am getting? 0.003 moles of, one second, 0.03. 0.03. Understand here, 0.03 moles of AgCl I am getting means how many moles of Cl minus would have been come out from the complex? From the complex, I would have received 0.03 moles of Cl minus. Understand? From this complex, if 0.03 moles of Cl minus comes out means automatically 0.03 moles of AgCl will be precipitated when it reacts with AgBr. Now, 0.03 moles of Cl minus is coming means what is the complex mole? 0.01. So, how many moles of Cl minus was present outside? How many moles of Cl minus should be there? 3, right? 0.01 is the concentration of this one, but 0.03 moles of Cl minus was out. So that means into 3. How many Cl was present outside? 3 Cl. Option D is the correct answer. Everybody getting the point how exactly I am solving the question? Once again, I will explain. That is very, very important, my dear students. Option D. Very good. So how exactly I did this question? Very simple. So this is the complex concentration 0.01 mole. AgNO3 I am passing. I am getting AgCl. Number of moles is 0.03. 0.03 moles of AgCl I am getting means with AgNO3 how many chloride ions would have been reacted? 0.03 only. If 0.03 moles of chloride ion is present outside means what is the concentration of complex? 0.01. How many moles of chloride ion should be present outside? Then I will get 0.03. 3 moles of chloride ion. So option D is the right answer. Clear? Perfect. Next question. Yes. Which of the following is not expected to be a ligand? Very simple question. Very simple. Yes, which of the following species is not expected to be a ligand? Yes, tell my dear students. In the meantime, I will drink a little bit water. I'm getting thirsty. Yeah, quick. C. Option B is the correct answer. Everybody, tell me, what is the definition for ligand? Ligand will act as a electron donor. Metal will act as a electron acceptor. Now tell me, my dear students, NH4 plus, the central atom, nitrogen, has 0 electrons. So it is possible for nitrogen to act as a ligand? No. So what is the correct answer? Option B is the correct answer. Option B is the correct answer. Everybody getting the point, my dear students? How to solve these type of questions, right? So with this, I'm finishing coordination compounds. Now the next thing, we are going to continue with D and F block elements. Now we are going to start with D and F block elements. One of the very easiest chapter. Try to tell the answer properly. D and F block elements. Yes. Yes. First question. Let me take now onwards we are going to solve with D and F block elements. The transition elements are not characterized by. So coordination compounds, if I talk about coordination compound, that those 14 questions are the different model question. Don't forget to note down the shortcut which I given in the beginning of the class. Okay, please do make a note of that particular shortcut. Now D and F block elements. First question. Quick, tell me, my dear students, first question. The transition elements are not characterized by. Transition elements are not characterized by. Basic only theory questions. Yes. What is the answer? Are not characterized by. We know very well it has the stability to form complex, several oxidation state, exactly chromium, manganese, tendency to form colored compounds. So which is not characterized by? Option C is the correct answer. Balance all those three options are characteristics of D block elements. So option C is the right answer. Next question. The paramagnetism of transition element compound is due to. Yes, paramagnetism. Paramagnetism behavior is attributed to what, my dear students? Pair the electron spinning in opposite direction, unpair the electron in D and F orbital, shared valence electron, unpair the electron in S or P orbital. What will be the correct answer? Yes, what will be the correct answer? Option B, we know paramagnetism means due to the presence of unpaired electron, but unpaired electron present in D and F orbital. So option B is the right answer. Why you people are confusing with C? Paramagnetism means it is only for unpaired electron. I think Lucifer is wantedly telling wrong answers. Yes. Next question. A property common to all transition metal. Yes. Property common to all transition metal. Yes. Is found in many different oxidation state. Definitely not. Because scandium, zinc and all having only one oxidation state. Produces colored compound? No. Once again, Zn2 plus scandium and all. Will scandium 3 plus that and all colorless. Has high electronegativity. See the spelling? Has a high electronegativity. That is also not an answer. What exhibit one oxidation state equal to the group number. So option D is the correct answer. Property common to all transition metal is that each of them exhibit one oxidation state equal to the group number. So option D is the correct answer. I'm observing Kriti, you entered A as the answer, then actually immediately you are changing. No, sir, I was not. I answered for previous question for sure. So option D is the correct answer. Option D is the correct answer. Next. Which dissolve in both acidic and basic solution? Different model question, my dear students. That's all. Which dissolve in both acidic and basic solution? Yes. Which dissolve in both acidic as well as basic solution. What do you guys think? Which dissolve in both acidic as well as basic solution? Very simple. I will give one hint. If one need to dissolve or react, whatever it is, both acid and base means it should be amphoteric. If it is amphoteric, reaction with acid also possible, reaction with base also possible. Out of given option, which is amphoteric? We know very well ZnO is amphoteric. Option C is the right answer. So option C is the right answer. Amphoteric behavior. That's all. I come in peace, sir. Just 1 or 10 question, no trouble, sir. Come to our regular batch. There I will hit your nose. So amphoteric means that one which will react with both acid as well as base. This is very, very important, my dear students. Amphoteric behavior. ZnO will exhibit amphoteric behavior. That's all. Very simple. Next question. Which ion is not colored? Which ion is not colored? Yes, which of the following ion is not colored? Yes, yes, yes. Which ion is not colored? For color property, what is the requirement? To exhibit color, there should be unpaired d electrons. If you take the oxidation state, option D will be the correct answer. Why? X minus 4 is equal to minus 1. X will be equal to plus 3. That is, aluminium exists in plus 3 state. So automatically we know if aluminium exists in plus 3 state, aluminium belongs to boron family, that is Ns2 Np3. If I remove 3 electron, any unpaired electron will be there, my dear students. No unpaired electron. So automatically option D will be the correct answer. There is no unpaired electron. It is clear? Done. Next question. So correct answer is option D is the correct answer. Next question. number of d electron in Fe2 plus is not equal to that of number of electron in Fe2 plus is not equal to that of. Yes. In Fe2 plus, how many d electrons we will be having? Iron means 4s2 3d6. So Fe2 plus means 3d6. Number of d electron is 6 is there. Now, is not equal to that of they are asking. Quick. Yes. Very simple. P electrons in neon 10. 1s2, 2s2, 2p6. 10 is there. This is correct. But they are asking not equal. S electron in Mg 1s2, 2s2, 2p6, 3s2, Mg12. So how many s electrons are there? 2, 4, 6. This is also correct. D electrons in Fe. So how many d electrons we will be having in Fe? Just now we know Fe is 4s2, 3d6, 6 electrons are there. Then answer will be option D. But check Cl minus. Cl minus means Cl will be having 17 plus 1 we will be having 18 electron. So 1s2, 2s2, 2p6, 3s2, 6, 7, 8, 9, 10, 11, 12, 18. So tell me, my dear students, how many p electrons are there? Here 6, here 6, 12. So this is only incorrect. But they are asking which is not equal only they are asking. So the correct answer is option D is the correct answer. Option D is the correct answer. So I think some of the other students came. Yes, Rushikesh, very good evening. Hafshana, good evening. Yes, very good evening, ma. Now next question. Yes. Zirconium and osmium have almost equal atomic and ionic radius. Because of what? Yes. Zirconium and osmium have almost equal atomic and ionic radii. Because of what? Yes. Exactly. Direct question. Very simple question. We know very well due to lanthanoid contraction. Next question. The most stable oxidation state of +3 is shown by. Most stable oxidation state of +3 is shown by. Yes, speed up, sir. Yes, I'm going to do, mark. But Rushikesh, before that, I know one of the students name Rushikesh. Are you that student? Please do let me know. Yeah, now I will speed up, my dear student. Don't worry, I will speed up now. Yes. Stable oxidation state. Sure, everyone be? Yes, sir. Let me check. CO3 plus. CO means what actually? 4s2, 3d7. So CO3 plus means we will be having 3d6 electron. Fe means 4s2, 3d6. So Fe3 plus means we will be having 4s0, 3d5. Now tell me, my dear students, which is more stable? Option D is more stable. So which is more stable? Option D is more stable. Very simple. Yes, Fe3 plus means 3d5 electron. Next question. Yes. Of the following element, which is not expected to display an oxidation state of +6 in any of its compound. Not expected. They are asking about not expected. The question is all about not expected. A. Exactly. Correct answer is option A. Why? Ti, scandium titanium 4s2 3d2. The maximum oxidation state is +4 only. This is the maximum oxidation state. They are asking about +6. So A is the answer. Next question. Last question from D and F block elements. So in the beginning of the class, coordination compounds, how to calculate the shortcut, how to calculate hybridization. For that shortcut I given. After that we discussed all different important model question from coordination compound. That one question what we solved, coordination compound plus mole concept plus solution chapter. That is very important even in advanced level. Next actually we started discussing D and F block elements question. So this will be the last question of D and F block. Next I am moving into P block elements. Let me check how many of you can able to tell. Tell me answer for this particular question. The dichromate ion is in equilibrium with chromate ion. Oxoanion has same oxidizing property in acidic and alkaline solution, better oxidizing property in acidic solution, better oxidizing property in alkaline solution, no oxidizing property in acidic or alkaline solution. Yes. Think what is the change of oxidation status happening, my dear students, here. Cr2O7 2 minus 14 minus 12 divided by 2 plus 6. Here also we will be having plus 6 state in acidic medium. D, B, what will be the answer? Yes. We studied, how many of you remember, in redox reaction, KMNO4 BNA, in acidic medium number of electron transfer is 5, in neutral medium 3, in basic medium 1. 135 for KMNO4. If I talk about K2Cr2O7 in acidic medium, what will be the change in oxidation state? +6 to +3. But in basic medium or neutral medium, any change in oxidation state is possible for chromium? No. Only in acidic medium, the N factor will be 3. So if I take this will undergo reduction. That means it will act as a oxidizing agent. Better oxidizing property in acidic solution. So D and F block element plus redox reaction, combined concept question. So the correct answer is option B is the right answer. Option B is the right answer. It is clear. Now next, shall we move into P block elements? Everyone is ready? Right? In alkaline solution, that is not possible. Fine. Now we will move into P block elements. P block elements or periodic classification. Last we will solve periodic classification. That will give you people motivation. Now let me start with P block element. Now I am going to start with P block elements. In NEET level, we are having only general properties. So try to tell the answer. First question. When KOH reacts with Cl2, what will be the product? Quick. Direct question. When KOH reacts with Cl2, what will be the products? From now onwards, please do remember, when KOH reacts with Cl2, the product will be KClO3. So, option C is the correct answer. Option C is the correct answer. Next question. In the solid state, SO3 structure. In the solid state, SO3 structure is. What will be the structure of SO3? Yes. Sure. A and B both are. Are you sure, my dear students? A and B both are. No. The correct answer is, at least now onwards, remember, option A is the correct answer. Very simple question from NEET examination that will make us wrong. So the correct answer is option A. It will exist as linear chain or cyclic trimming. Okay. It will exist as a linear chain or cyclic trimming. Next question. CO2 is isostructural with. CO2 is isostructural with NO2, C2H4, SnCl2, HgCl2. Yes. Isostructural, that means same structure should be there, right? Same structure. If I talk about CO2, what is the CO2? It is a linear structure. Which one will be having linear structure here? Which one will be having linear structure? Very simple. Please do make a note, HgCl2. HgCl2 will be having a linear structure, not C2H4. C2H4 is not linear. NO2 also, it's not linear. We know very well. So automatically, what is the correct answer? HgCl2. Option A is the correct answer. Option A is the correct answer. Next. Which of the following is an organometallic compound? Which of the following is an organometallic compound? What is organometallic compound, sir? I will give one idea. Metal is directly attached to carbon. That is called as organometallic compound. Metal is directly attached to carbon. Now tell me. Methyl lithium, lithium dimethylamide, potassium acetate, sodium ethoxide. Ethane is sp3 hybridization, tetrahedral, no, it is not linear, ma. What is the correct answer? Methyl lithium. So CH3Li. Metal is directly attached to carbon. Now onwards, please do remember what is the which of the following is an organometallic compound. Methyl lithium is an organometallic compound. Most reactive form of phosphorus. Which is more reactive form of phosphorus? White, red, black, yellow. Yes. which is the most reactive form of phosphorus? We all know this, right? Property. White phosphorus is more reactive form of phosphorus. White phosphorus is more reactive form of phosphorus. Next question. Which acid will you use to dissolve lead to oxide? Which acid we will use? Yes. Which acid I will use? Yeah, yes, white poisoning. Very good. This one. Which acid will you use? Hey, why this much tongue twister? Which acid will you use to dissolve lead to oxide? Think, if I add lead oxide in HNO3, what I will be getting? Lead nitrate I will be getting, right? I will be getting lead nitrate. This lead nitrate is soluble in water. So, due to this property, nitric acid is used. Due to this property, what will happen? We will be using nitric acid to dissolve lead to oxide. Option A is the correct answer. Next question. Sulfur dioxide bleaches coloring matter by, what is the property? Yes. Which bleaches coloring matter. Bleaches coloring matter means that is the process called as oxidation. That means sulfur dioxide need to undergo reduction. It will undergo reduction to sulfide. Option B is the correct answer. So it will undergo reduction to sulfide, so that bleaching action is a oxidation property. Yes. Once again. It is undergoing reduction. That means oxidation, dehydrogenation, both are same, no? This option. Yeah, dehydrogenation means removal of hydrogen. Removal of hydrogen is nothing but oxidation. Yes, A and C. I think B only. Sulfur dioxide only they are asking, right? By undergoing reduction only, no doubt. By undergoing reduction only. So option B is the correct answer. Next. Which of the following is not hydrolyzed? Which will not undergo hydrolysis? Which of the following will not undergo hydrolysis? Yes. Which of the following will not undergo hydrolysis? Very simple. Nitrogen, phosphorus, arsenic, antimony. Right? Remaining and all fluoride. Tell me, I will tell nitrogen. B is the answer. Why? Because in nitrogen, there is no presence of d orbital. So automatically, option B is the right answer. Very simple. Option B is the right answer. Yes. Next question. Reaction based question. Lead sulfide. If I heat in air, I am getting A plus lead sulfide. At high temperature with no air, I will be getting lead plus sulfur dioxide. Identify A. Yes. What will be the reaction? Definitely we know what is present. Since oxygen is there, A contains oxygen. So in which of the option oxygen is there? PbO, PbSO4. Both are possible. A or B. Option D is there, right? So I will go with A or B. I will go with A or B. when Sn is treated with concentrated HNO3, what is the product we will be getting? Sn with concentrated HNO3. If you people want, I will give the clue by writing the chemical formula. Shall I write? Yes. When Sn reacted with concentrated HNO3, we will be getting H2SNO3. When Sn reacted with concentrated HNO3, we will be getting H2SNO3. What is the name of this, my dear students? Tell me. H2SNO3. It is called as metastanic acid. This is called as metastanic acid. So option C is the right answer. So automatically option C is the right answer. So these are all the different model question you guys need to do when it comes to P block element. One thing, my dear students, all my existing students know very well, if you are new students watching my lecture means, for this P block element, I did one tabular column. One simple tabular column. If you people have an idea on that tabular column, solving any question from P block elements will be very easy. From group 13 to group 18, I created one simple tabular column. If you people want that tabular column, once the class get over, please do let me know in the comment section. After the class, let me know in the comment section. If you people want, please do let me know in the comment section. I will share the tabular column. Okay, fine. Yes. Now, the last topic to give you motivation. Which chapter I am going to take, my dear students? Any idea? Yes. Which chapter? I am taking periodic table. Periodic classification of element. Will you guys tell the answer quickly? Let me keep 30 seconds. Is everyone is ready? Because one of the very easiest chapter, periodic classification of elements, periodicity and periodic classification of element, is everyone is ready to solve in less than 30 seconds? If so, I will keep the timer for 30 seconds. Shall we solve? Is everyone is ready? Done. Shall I keep 30 seconds? I will read the question, then I will give 30 seconds. In P block, I studied only your notes. I don't study NCERT line by line. No other notes too, sir. Thank you so much, ma'am. So other students, please do make a note of my tabular column, which I will share after the class get over. If you people want, once the class get over, please do remind me in the comment section so that automatically I will share in WhatsApp. Okay? Yes. 45 seconds. Okay. Let me change it to 45. Ready? So they are asking electronic configuration of element is given, atomic number, group number of element, yes, which is just below the above element in the periodic table. Let me start the question quick. 45 seconds. Let me know the answer. Quick. Periodic table and its properties. Yes. Very good. Correct answer is option C is the correct answer. Very good. Why? The given electronic configuration, atomic number is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 electrons are there. That means atomic number is 15. When atomic number is 15, we know very well group number is 10 plus 5 valence electron. Now what they are asking, atomic number and group number of the element, which is just below the above element in the series. So 33 and then 15. It is clear. Anybody is having any doubts? Done? Okay, next question. Second question. The same 45 seconds. A trend common to both group 1 and group 17 elements in the periodic table, as atomic number increases, they are asking. 45 seconds. I think 45 seconds is too much. You people are giving answer very quickly. I'm happy. Or that is previous question answer. Group 1 and then group 17. Same property they are talking. So automatically what will be the thing? Option C is the correct answer. Increase in atomic radius. If atomic number increases, atomic radius increases. Group 1 and group 17. C is the correct answer. Next question. Element with atomic number 47 belongs to period and group. Element with atomic number 47 belongs to period and group. Yes, what will be the answer? Yes, exactly. Option D is the correct answer. How option D? 47 means what exactly we will be having? Before that we will be having krypton. Krypton 4D10 5S1. So automatically period is 5. What will be the group number? 10 plus valence electron, 1 valence electron. So group number is 11. 5 and 11 is the answer. Option D is the right answer. Next question. A non-metal will have smaller dash when compared to metal of same period. If I compare in the same period, what will be different? Yes. What will be the answer? Ajit Kumar. A non-metal will have smaller ionization potential. Non-metal means greater electronegativity. It has greater tendency to accept an electron. So it is easy for us to remove. No, higher ionization potential. They are asking smaller. So what is the answer? Option C. Option C is the answer. Atomic radius. Next question. Transition elements all are metallic because of their. Why all are metallic? Transition elements all are metallics. All are metallic in nature due to dash. Yes, quick. Why all transition elements are metallic? Exactly. What will be the correct answer? C. Because of the S electron. Why it is not reading? I think you people are not telling on time. Next question. Electron of an atom lost when ionization occur is the one with, yes, which electron of an atom will lose when ionization occur? Yes. What will be the more suitable correct answer? We know very well, if I want to remove an electron, automatically outermost electron will be removed. Outermost electron with highest orbital quantum number. Option C is the correct answer. The key word is outer shell electron. This is very important word. So option C is the Right answer. Very good. Fantastic. Next question. Which of the following cannot be isoelectronic? Yes. Which of the following cannot be isoelectronic? Isoelectronic, that means same number of electron. This concept is applicable only for what, my dear students? For ions. But here, what they are exactly doing? They are comparing atoms. For two different atoms, cannot be isoelectronic. That is not at all possible. Sir, could you make the lecture a bit longer? Please, it's really helpful. Okay, sure, ma'am. I will keep in mind. So, from next class onwards, I will bring more question because back-end team told we are limited to solve only 50 questions. That is why actually I am doing like this. So, from next class onwards, I will try to solve more than 75, 80 questions. Okay? Yeah, sure. From next class onwards, I will keep this in mind. Done. So, option D is the correct answer. Next, the element with lowest atomic number and having ground state electronic configuration of n-1 d10 ns2 np3 is placed in the, where exactly we will place? And then one more thing, my dear students, in the beginning of the class, already I given the shortcut to solve coordination chemistry hybridization based question. Please do make use of that shortcut. With the help of that, any complex related hybridization question, we can able to solve in less than 30 seconds. Once the class get over, I will share the only one tabular column with respect to P block elements. That tabular column is more than sufficient for P block elements. Okay. If I forget also, please do let me know in the comment section tabular column. I will share. Okay, once the class get over. Yes, element with the lowest atomic number and having ground state electronic configuration. Very simple. The element with lowest atomic number means what is the possibility we are having? This n value can be d electron is there. So 4s2, 4p3, 3d10. So having ground state electronic configuration 3d10, 4s2, 4p3. The element with the lowest atomic number is, this is the only possibility. So automatically then what will be the period? If n-1 is 3, we will be placing in the fourth period. Option B is the right answer. Option B is the right answer. Next question. Yes. Which of the following sequences represents the correct order of increasing stability of +3 oxidation state? They are dealing with boron, aluminium, gallium, indium. Here, nitrogen, phosphorus, arsenic, antimony, bismuth. Okay. Stability of +3 oxidation state. Yes. On moving down the group, what will happen, my dear students? Lower oxidation state become more stable. On moving down the group, lower oxidation state become more stable. So automatically, which effect is present there? Inert pair effect. What is inert pair effect, sir? Imagine outermost electron will be there, nucleus will be there. If the inner electron between these two has poor shielding effect, if it is having poor shielding effect, shield, we know the meaning, right? If this inner electron is having poor shielding effect, automatically what will happen? Outermost electron will be attracted by the nucleus. So because of this, automatically this outermost electron cannot take part in reactions. This effect is called as inert pair effect. So now tell me, so what will be the correct order? Stability of +3 oxidation state. So automatically we know very well. Now the question is very, very easy. Inert pair effect. Bismuth will be having lower oxidation state +1. Nitrogen is more stable in +3. So bismuth is very less. Option C is the correct answer. Then next question. The correct order of increasing atomic size of element sulfur, silicon, oxygen, nitrogen. Okay, this is previous question answer, no? What is the previous question answer is option C. I will finish this. Next question. Yeah. Correct order of increasing atomic radii. Correct order of increasing atomic size of elements. Sulfur, silicon, oxygen, nitrogen. Yes. Very simple. First, write the periodic table. Nitrogen, oxygen, sulfur, carbon, silicon. Left to right, atomic size decreases. Top to down, atomic size increases. Atomic size increases. So, increasing order. Which one is very least? Oxygen is very least. Oxygen is very least. Oxygen. After oxygen, nitrogen, nitrogen, nitrogen. After nitrogen, sulfur, silicon or silicon, sulfur. We know very well, compared to this, silicon will be having more size. Option A is the correct answer. Option A is the correct answer. It is clear. Option A is the correct answer. Next question. Which of the following pair include elements with almost same covalent radii? The question is all about covalent radii. Quick. Same covalent radii. Check. Hydrogen, helium. Bri, this will be having same covalent radii. Nitrogen, oxygen. Carbon, nitrogen, oxygen. Next, what we will be having? Sulfur and then chlorine. So, we will be having fluorine, chlorine, bromine, iodine, sulfur. Which one will be having same? They are comparing nitrogen, oxygen. They are comparing iodine and bromine. Then they are comparing hydrogen, helium is not the answer. Even I know that is not the answer. So next actually they are comparing sulfur and chlorine. Which one will be having almost same covalent radii? Same covalent radii is shown by sulfur and chlorine. Option D is the right answer. Sulfur and chlorine. Option D will be the correct answer. Next. Atomic sizes are not significantly different for the series of element. Previous question answer is D. Yes. Atomic size are not significantly different for the series of element. Yes, yes, yes. Yes. What will be the correct answer? Yes. Very simple. I given the CRMN FeCO, direct trend in D block elements. Right. So scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. What is the order I thought you guys? First actually scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel will be having same, then copper, zinc. So automatically MnFeCO. These and all will be having almost same size because of lanthanoid contraction. Option D is the right answer. Option D is the right answer. Next question. Species with a radius less than that of neon. Yes. Neon is a neutral atom. Anion will be having more charge than neutral atom. Then neutral atom will be having more charge, more size than cation. So anion will be having more size than neutral atom. Neutral atom will be having more size than cation. So which is having less size? Cation. So out of cation, this is plus charge plus 2. More the charge of cation, lesser is the size. More the charge of anion, greater is the size. So the question is all about radius less size. So what is the answer? Option A is the correct answer. Option A is the correct answer. Next. In which of the following is there a consistent decrease in atomic radius as atomic number increases? Quick. In which one? Yes. In which of the following there is a consistent decrease in atomic radius as atomic number increases? Lanthanides and all, definitely not. Transition element, just now I given the order. Option B is the right answer. Just now I given the order for transition elements, right? So almost it will be having similar. So option B is the correct answer. Representative. Halogen also will come under the category of representative element. Option B is the right answer. Last question for the day. Which is the correct order of size of O minus, O2 minus, F and then F minus? As I told you earlier, neutral atom, then we will be having O2 minus. So O2 minus will be having greater size. O2 minus, O2 minus. After that, neutral atom will be having very least size. So where neutral atom is having very least, here anion dimension. So this is not the answer. If I compare between A and D, FF is there. Between O minus and then F minus, which one will be having greater size, my dear students? We know very well carbon, nitrogen, oxygen, fluorine. What will happen? Atomic size decreases. So automatically corresponding anionic size also decreases. O minus will have greater size than fluorine minus. Option D is the correct answer. Option D is the correct answer. So with this exactly I am finishing today class, my dear students. All the questions we discussed. So once again I am telling, so the main thing is in the beginning of the class for coordination complex, I just given the shortcut to calculate hybridization. So what you guys need to do, download the class notes. Next, when it comes to P block element, I can able to see you people are struggling little bit in P block elements. For that, I prepared one tabular column. I will share that tabular column also for you guys. Okay. If I forgot to share, please do let me know in the comment section. After the class get over, I will definitely share. So homework is solve more and more question. Some more 50 question I will share in our WhatsApp group. Please do download those questions from the WhatsApp and try to solve. Okay. In class 50 question, in WhatsApp homework 50 questions. So total 100 question, my dear students. You guys can able to do. Okay. With this, I am finishing today class. Thank you so much for listening. Let me show the leaderboard. So yes. So attempted question. Some of the question I think it didn't take, right? Maybe some of the maybe network glitch or sometime. Okay, my dear students. With this, let us wind up. Thank you so much for listening. Take care. Don't forget to revise the shortcut. Inform to your friends also. Don't be very selfish. So, okay, my dear students. Take care. Bye-bye. See you. Okay, Makriti. See you in the class. Yes. Okay. Take care. Bye-bye. See you.